Alright, this video is for problem number 8 on homework 6.1. And the question asks you to find the definite integral from 0 to 12 of x divided by square root of x plus 4. And they tell you to use integration by parts. And once again, for a reminder, with integration by parts, you want to choose a u that is something fairly easy to differentiate, and you want to choose something that's going to represent dv that's easy to anti-differentiate. So in this case, I let x stand for u, and then 1 divided by x plus square root of x plus 4 is going to represent dv. So the du is going to be 1 dx, right? And v, in order to get v, we can rewrite dv. So we'll rewrite this as x plus 4 raised to the negative 1/2. And if we do anti-differentiate this, right, we have to add 2 halves to it in order to get back to 1 and reverse the power rule. And when you do that, you end up getting 2 square roots of x plus 4. We can go over that in a separate video if need be. In any event, once again, the formula for integration by parts is u times v minus the antiderivative of v du. So we let u be x, and we let v be 2 square roots of x plus 4, and in that case we come out with 2x square roots of x plus 4, okay, minus the antiderivative of v du, or 2, which we'll leave on the outside, square roots of x plus 4 dx. And eventually we're going to evaluate from 0 to 12, but the easiest thing to do initially is just to find the antiderivative. So in finding this antiderivative, we can rewrite this. So let's rewrite, right, we'll leave the left-hand side alone and let's just work inside the integrand. And we have x plus 4 raised to the 1/2, right? Fractional powers indicate you're doing some sort of radical expression. Okay, and again, it's just another reversal of the power rule. So we end up with 2x square roots of x plus 4 minus 2 x plus 4 to the 3/2, and then we're going to multiply by the reciprocal 2/3 to compensate. And finally, we'll get 2x square roots of x plus 4 minus 4/3 x plus 4 raised to the 3/2. And now the next step is to evaluate this expression from 0 to 12 because we're finding a definite integral. So when we plug in, we get 24, right? 2 times 12 is 24, times the square root of 12 plus 4 minus 4/3 12 plus 4 raised to the 3/2. This whole quantity minus 2 times 0 is 0, so we get 0 on the left-hand side, minus 0 plus 4, which is 4, so 4/3 times 4 raised to the 3/2 power. Okay, so we work a little bit more inside. 12 plus 4 is 16 in this case. Square root of 16 is 4. 24 times 4, 96. Again, 12 plus 4 is 16. Square root of 16 is 4. 4 cubed is 64. So we get 4 times 64 over 3. The whole expression's over 3. And then we end up subtracting, which turns into addition at this point because we can just distribute that negative in. Let's see. Square root of 4 is 2. 2 to the 3rd is 8. So we get 32 thirds. And 4 times 64 is 264, I think it is. Yes. So we have 96 minus sorry about that, 256 thirds plus 32 thirds. Okay, and that's 96 minus 256 minus 32 is 224 thirds. We convert 96 back into thirds, and we come out with 288 thirds minus 224 thirds, which should then come out to 64 thirds as your answer. So once again, to summarize, we just took the antiderivative using integration by parts, and then we just substituted in the values from 0 to 12, used the fundamental theorem of calculus, and came out with 64 thirds as our answer. Hope this video certainly helps you guys out with this question, and if there are any more, please feel free to post them on Sakai. Thanks a lot.